Hi everyone, welcome to the video for the week 9 MME1 workshop class. So obviously if you're watching this video you've submitted your solutions to this week's workshop. So what I'm going to do basically in this video is just run through the solutions. Okay, so in this week's workshop we had 3 questions. Okay, the first question looked at definite integrals, the second question looked at the second fundamental theorem of calculus, and then the third question looked at using properties of odd and even functions to calculate integrals. So basically I'm just going to work through the solutions. I'll work through them reasonably quickly, but because obviously you've got the video so you can go back and look at them slow them down if you like, and look at them step by step. But I'll basically just kind of keep working through them question by question, and then if you've got any questions, then you can obviously email me, get in touch with me, or you can drop into the other workshop this week, okay, which is on Thursday from 10:30 until 12:30. Alright, so let's start with question number 1. Alright, so question number 1 is the integral from 0 to pi on 2 of sine x minus cosine 2x. Okay, so basically what we're going to do here is just do a simple integral. Okay, so remember the 4 steps that we spoke about. So check, can you do it with the normal integral rules? If so, great. If you can't do it that way, go to the second step. The second one is, can you make some sort of substitution, rearrangement? Can you expand it or factorize it or break it into parts? If you can't do that, go to the third step. Can you use some trig identity? So can you substitute in for sine or cosine or something? If you can't do that, then you go to the last step, which is using integration by substitution. Alright, so they're the steps that we spoke about in the lecture. Alright, so with this one, we can just integrate this normally. So the integral of sine x is minus cosine x, and the integral of minus cosine 2x is minus 1/2 sine 2x. Okay, and this is from 0 up to pi on 2. Alright, so then it's just a matter of substituting in the values. So minus cosine of pi on 2 is 0, and minus, so sine of 2 pi on 2 is sine of pi, so that's also 0. Alright, then we subtract, we sub in 0. So minus cosine of 0 is minus 1, and then sine of 0 is just 0. Okay, so what we end up with here is simply 1. Okay. Alright, so what I might do is I'll use a new board for each question. So this was part A. Okay. Alright, part B is the integral from 0 to 1 of 2x take 1 to the 10 at dx. Alright, so again we look at this, can we take a normal integral? In this case we can. We're going to use the process of the opposite of the chain rule. So the integral here is going to be 2x take 1 to the 11 divided by 11, and then multiplied by 1 over 2, because we have to divide by the derivative of what's in the brackets here. Okay. Now remember, this is from 0 up to 1. Now often it's easy to take the whole fraction out the front. Alright, so what we end up with is 1 over 22, and then we've got 2x take 1 to the 11 from 0 to 1. Alright. So this will give us 1 over 22, and then we're going to substitute in 1. So this will just simply be 1 minus, and then we sub in 0, and this will be minus 1. So we'll have 1 minus 1 is 2, so we'll have 2 over 22, which is 1 over 11. Alright, part C. So the integral from 4 to 5 of x plus 2 over x squared take x take 6. Alright. Now this time, we can't just use one of our simple integral rules, because it's in a form that doesn't match any of our rules. So what we're going to need to do here is go to step 2. So can we simplify this? Now this is a bit of a tricky one because you might not recognise that you can simplify it. However, if you tried to go further and use the substitution, you would find that you couldn't use substitution. So actually we're going to stop at step 2 here. I'm going to factorise this. So before we integrate, this is going to be the integral from 4 to 5 of x plus 2 over, and on the bottom line here, we've got x take 3, x plus 2. So we haven't integrated at this point, we've just simplified. Now we can cancel this out, and so what we're left with is the integral from 4 to 5 of 1 over x take 3 dx. Okay, so now we can integrate this. So the integral of this is ln x take 3, okay, from 4 up to 5. Now just remember, because we're doing definite integrals, we don't need our integrating constant. Okay, so then substitute our values. So we have ln of 2 minus ln of 1. ln 1 is 0, so our answer is ln 2. Alright, part D. So we've got the integral from minus pi to pi on 2 of 1 over sec x cosec x dx. Alright, so at this point, obviously nothing that we can use to simplify. However, we can substitute in some properties. Alright, so this is really the same as 1 over sec x times 1 over cosec x. Alright, now 1 over sec x is simply 1 over cos x, which gives us cosine x. And 1 over cosec x is 1 over sine x, which gives us sine x. So this can be simplified to the integral from minus pi to pi on 2 of cosine x sine x dx. Now in this case, we need to use the process of substitution. Alright, now it actually doesn't matter in this case which one we use, okay? I'm going to pick sine x only because the derivative of sine is cosine, so then I don't need to do any rearranging. So I'm going to say let u equal sine x, so du dx is equal to cosine x. Now remember, when we're doing definite integrals, we also need to change the bounds, okay? So when x is equal to pi on 2, u, we need to sub it in here, so this will be 1, and when x is equal to minus pi, u will equal, so when x is equal to minus pi, u will equal 0. So this integral now becomes the integral from 0 to 1 of du dx times u dx, which is just the integral from 0 to 1 of u du. So this will be 1/2 u squared from 0 to 1, which will be 1/2 of 1 take 0, which will give us 1/2. Okay? Sorry, just changing my text there. Alright, so part E. So we've got the integral from e to e squared of 1 over x ln x dx. Now remember, whenever you've got 1 over two functions, just like we did before, this is 1 over x times 1 over ln x. So remember, you can always break your functions out like this. So what I'm going to do here is I'm going to say let u equal ln x, okay? So then du dx is equal to 1 over x, alright? Which is my other part, which is what I want. Now, also need to change my bounds, so I'm going to have when x equals e squared, u equals ln e squared, which is 2, and when x equals e, u equals ln e, which is 1. So my integral becomes the integral from 1 to 2. Now, 1 over x is du dx times 1 over u dx. And if we simplify this, we get 1 over u du. And if we integrate, so we get ln u from 1 to 2. So this is ln2 minus ln1, which again is ln2. Alright, part F. So we've got the integral from 0 to pi on 2 of cosine x over 2 plus sine x cubed. Alright? Now again, we've got two options. We can either have this one to be u or this one to be u. Alright, so we can't do the simple integration, we can't do any of the other methods, so we're going to have to use substitution. Now remember, we picked the one that has the higher power, so this is cubed, so we're going to pick what's in the brackets here. Not including the cube, just what's in the brackets. Alright, so we'll say let u equal 2 plus sine x, and therefore du dx equals cosine x. Now when x equals pi on 2, substitute in here, u will be 2 plus 1, which is 3, and when x equals 0, u will be 2 plus 0, which is 2. So this integral, if we rearrange it, becomes the integral from 2 to 3 of du dx over u cubed dx, which is the integral from 2 to 3, 1 over u cubed du. Now, integrate this. Now remember, u cubed is really the same as, or 1 over u cubed is the same as u to the minus 3. Alright? So, integral of this will become increase the power, makes it u to the minus 2 over minus 2. Okay? From 2 to 3. Now remember, you can take the fraction outside of the bracket, which makes it easier. So you'll just have negative 1 over 2 out here. Okay? So this is equal to negative a half. Substitute our values in. Okay? So this is 1 over 3 squared, which is 1 over 9, minus 1 over 4. Okay? And then you've got a bit of a fraction that you can work with there. So if we got 1 over 2, so this will be, and you can do this yourself, this is just a little bit of algebra, but basically this will be minus 5 over 36. Okay? Get a common denominator here, 4, 9, and so we'll end up with 5 over 72 as our answer. Okay? Now, just remember, with those fractions, I've done that pretty quickly, but basically what I've done is just found a common denominator and multiplied the top numbers. Okay? So that's part F. Part G. So the integral from 0 to 2 of x over the square root of 5 minus x squared. So again, look at our two parts. We're going to need to use the last method, which is substitution. Now, obviously, the derivative of this part is going to be some multiple of this. So I'm going to say let u equal 5 minus x squared, du dx equals minus 2x. And this time they're not equal. Okay, so we need to remove a factor. So if we divide both sides by minus 2, we'll get minus a half du dx equals x. Okay, which is the part we want. Now, we also need to do our bounds. So when x equals 2, u equals 1. And when x equals 0, u equals 5. Alright. Now this is where it's a little bit interesting, because now when we rewrite the integral, this is going to be the integral from 5 to 1. Now that's okay, however, just don't fall into the trap of thinking the higher number needs to be on top. Because we've made a substitution, we've actually flipped our integral around. But we need to keep it as the bounds say. So if x equals 2 and u is 1, that's the top value. And then if x equals 0 and u is 5, that's the bottom value. Alright, so they've got to match up. They don't need to necessarily be the higher number on top. So this, if we make our substitution, x is minus a half du dx. And then we've got u to the half, or the square root of u dx. Simplify. So remember, take your fraction out the front, put stuff up to the top line. So minus a half, the integral from 5 to 1 of u to the minus a half du. And then we can do the integration. Alright, so this will be negative half. Integral of this will be u to the half, okay, divided by a half, which is the same as multiplying by 2. Alright, so dividing by a half from 5 up to 1. Now, these factors will cancel out, okay, so we'll just end up with minus u to the half from 1 to 5. Substitute in our values, so 1 will be 1, and this will be root 5, times by the minus, so we get a root 5 minus 1. Okay? So substitute the 1 in, substitute the 5 in to get our two values. So we end up with root 5 minus 1. Okay, part H. So we've got the integral from 0 to ln3 of e to the x, 1 plus e to the x. Now this one's a little bit different because there's no powers of x here. So we've got to look at the two parts, this part in the square root and then this part, and work out which one we're going to let be u. Now, in this case, it's going to be this one, because we want the derivative of this to be this, and we know that the derivative of a constant is 0. If we pick this one, the derivative would be e to the x, but it wouldn't be 1 plus, and we can't add a 1 to our function, to our derivative. We can only multiply by a factor. Okay? So I'm going to say let u equal 1 plus e to the x. So du dx is equal to e to the x, which is our other part. Again, when x equals ln3, substitute in here. So u will be 1 plus e to the ln3, which will be 4, and when x equals 0, u will be 1 plus e to the 0, which is 2. So our integral becomes the integral from 2 to 4 of du dx times the square root of u dx. Simplify, so this cancels out, we'll have u to the half du. Alright, substituting our values, so, integrate first. So this will be u to the 3 over 2 divided by 3 over 2, which is the same as timesing by 2/3. Okay? So when we divide by 3 over 2, or any fraction, it's the same as multiplying by its inverse. Okay? And this is from 2 to 4. So this will be 2/3, and then we've got 4 to the 3 on 2 minus 2 to the 3 on 2. So this is 2/3. Now 4 to the 3 on 2 is 8, and 2 to the 3 on 2 is 2 root 2. So if we multiply this through, we'll get 16 minus 4 root 2 over 3. Okay? And we can't really simplify that any further from there, so we just leave it in that form. Okay. Alright, next one, I. So integral from 0 to 1 of e to the root x on square root x. So again, this is going to be substitution. Okay, so I'm going to say let u equal the square root of x, which is x to the half. Okay, so du dx is 1/2 x to the minus a half. Now this can be rewritten as 1 over 2 times 1 over root x. Alright, which is important because it relates back to what we've got here. Okay, so remember this is really e to the root x times 1 over the square root of x. Okay, again, do our values. So when x equals, so we want 1 over root x, but we've got 1/2, so therefore 2 du dx will equal 1 over root x. Okay, for our substitution. So then, when x equals 1, u equals 1. When x equals 0, u equals 0. So our bounds are actually the same this time. Okay. Now our integral in this case becomes the integral from 0 to 1. Now we've got e to the u, and then we've got 1 over root x, which is just 2 du dx. So if we simplify this and take our factor out the front, we've just got e to the u du, which is simply 2 lots of integral is the same. Substitute in our values, so 2 lots of e to the 1 minus e to the 0. So this is 2 lots of e minus e to the 0 is 1 times 2 is 2. So 2 times e is 2e, and 2 times 1 is 2. So we've got 2e take 2 in this case. Alright, I'll just change texts again. Okay, so the next one we've got is j. Now this one's a little bit more complicated. So we've got the integral from -3 to 0 of 15x squared over the square root of 1 minus x. Now the first thing I'm going to do here is I'm just going to take the 15 straight out the front. Okay? So I'll just put the 15 out the front just to simplify our fractions here. Alright. Now you could leave it in, it doesn't make any difference. So what I'm going to do is I'm going to say let u equal 1 take x. So du dx equals -1. Now, you'll notice I haven't picked the highest power of x. Now in this case, I can't do that because if I pick this, the derivative of this isn't going to have a 1 in it. So this one's a little bit different. This is one of those ones where the derivative is 1, which gives us extra flexibility. So what we're going to have to do here is we're going to actually have to change the whole integral from from x to u. All right. So we can write this as du equals minus dx. Okay. Now, when u equals when x equals 0, okay, u equals 1. And when x equals -3, u equals 4. Now to do our substitution, we actually are going to need to change this into u. So we can rearrange this in terms of x. So x is actually equal to 1 minus u. So therefore x squared is 1 minus u squared. Alright, so this is a bit trickier substitution. So if we substitute all of that information in, what we end up with is 15 times the integral from 4 to 1. Now on the top line we have x squared, which is this, 1 minus u squared, over the square root of u. Now instead of dx, we have minus du. So I'm going to put du and put my minus out the front. So I've ended up with this. So I've changed the whole integral into an integral with respect to u. So, if we now expand this, so we go back to the second option, expanding it. So this is going to be the integral from 4 to 1. So we've got 1 minus 2u plus u squared on the square root of u du. And now we can separate this into parts. So this is minus 15, integral from 4 to 1. So this is 1 over u, which is u to the minus a half, and we've got minus 2u to the half plus u to the 3 over 2 du. Now remember, at this point, I still haven't actually integrated anything. All I've done is divided each term by the square root of u. And I've put my powers to the top line because it makes it easier for my integration. So now I'm going to integrate this. So I've got minus 15. Now, u to the minus a half becomes u to the half divided by a half, which is 2u to the half. Then we've got this one, so we've got minus 2 u to the, so this will be u to the 3 over 2, but then we need to divide by 3 over 2, which is the same as multiplying by 2 over 3. So we'll have minus 4 over 3 u to the 3 over 2. Alright? And then finally, we've got this one, so this will be plus, so increase the power, so this will be 2/5 u to the 5 over 2. Alright? From 4 up to 1. Okay? So now, we need to substitute in our value. So we've got minus 15 out the front. Now if we put 1 in, okay, we've got 2 minus 4 over 3 plus 2 over 5. Okay? Subtract, and then we need to put 4 in. Okay, so if we put 4 in here, okay, we've got 2 times the square root of 4, which is 4. Put 4 in here, so 4 to the 3 over 2 is 8, so this will be minus 16 over 3. And then 4 to the 5 over 2 is 32, so this will be plus 64 over 5. Now, what we've basically got here is a big heap of fractions, okay? However, we can multiply them all through by 15, or we could just use our calculator. Just to show you, I'll multiply through by 15. So this will give us minus 30 plus 20 minus 6. And on this side, we'll have minus 60 plus 160 minus 192. Now if we work this out, we get minus 16 minus 92, which gives us our answer of 76. Now obviously that's quite a lengthy problem, okay? However, it's the same process. You just need to use a couple of the processes within this problem. So we started off, we needed to actually switch the whole integral from a u to an x, from an x to a u, alright? So if you get one that doesn't seem to fit into one of the 4 categories that we spoke about, then perhaps look at, okay, is the derivative of one of these functions 1 or negative 1? If it is, then you can use this trick where du equals dx or du equals minus dx. Okay? Alright, last one for question number 1. Okay, so part K. So we've got the integral from 1 to e to the 5 of the square root of 9 minus ln x on x. Okay. Now remember, this is again the same as the top line multiplied by 1 over x. Okay? So my derivative in this case, you might think, okay, my derivative should be 1 over ln x, because the derivative of that is 1 over x. However, we need to take the whole thing here, okay? So we can't have any constants. So I'm going to say let u equal 9 minus ln x. So du dx equals minus 1 over x. So minus du dx equals 1 over x, okay? Now when x equals e to the 5, u equals 9 minus ln 5, which is 4. And when x equals 1, u equals 9 minus ln 1, which is 0, 9 minus 0 is 9. So this is equal to the integral from 9 up to 4 of square root of u times by minus a half, minus du dx. Yeah. So if we simplify this, integral of u to the half du from 9 up to 4. Okay. So my text is almost running out. Now we can integrate, so this will be u to the 3 over 2 times 2/3, so minus 2 over 3 from 9 up to 4. Minus 2/3, substitute in 4 to the 3 over 2, which gives us 8. Put 9 in, okay, which gives us 27. So we end up with minus 2 over 3 times 9 minus 19, which is 38 over 3. Okay. Alright, so that's the end of question 1. Alright guys, let's go on to question number 2 now. Okay, so in question number 2 you're asked to use the second fundamental theorem of calculus. Alright, so 2 part A, the first question says that f of x is equal to the integral from x to 4 of sine 1 minus t squared dt. Now in this question you're asked to find f dash x. Now to find f dash x you're going to use the second fundamental theorem. However, you can only use that, remember, if we are integrating from some constant up to x. In this case we're integrating from x to 4, so we need to swap them over. Now with our rules of definite integrals, we know we can do that by multiplying by a negative. Okay? Alright, so now this is still capital F of x, and then we can say, okay, therefore f dash x, we can now apply the second fundamental theorem of calculus. So this will be minus sine 1 minus, and we substitute in x squared, okay? And that's our answer. So that one's reasonably straightforward, okay? So just remember, you can only use the second fundamental theorem if you're integrating from a constant up to x, alright? Now part B is the, so we're told g of t is equal to the integral from minus 1 to t squared of s plus 2 over e to the s take 1 ds. Now in this case, we are in the right form. We've got a constant up to some value, in this case of t. So t is our variable, and we're integrating with respect to s. Now in this case, we have to be a little bit careful because even though we can use the second fundamental theorem, we don't just have t, we've got t squared, so we have to use the chain rule. So therefore, g dash t is going to be the derivative of this, which will be, so we substitute in, so we'll get t squared plus 2 over e to the t squared take 1, okay, but then we need to multiply by the derivative of this, which is 2t, okay, because we need to use the chain rule. Alright, so this is how we do part B. So a couple of tricks there when you're using the second fundamental theorem of calculus. Okay. Alright, now on to the last question for today, which is question number 3. Okay, we've got 3 parts to question number 3. Alright, so the first part of question 3 gives us the integral from minus 1 to 1 of x take 1 cubed plus sine x minus 15x dx. Now I'm going to do this one a little bit differently. What I'm going to do is we basically need to use, the question says to use properties of odd and even functions if applicable. Okay. Now remember, to test if something is odd or even, what you can do is you can find f of minus x for each function. And if it's equal to minus f of x, that means it's odd. If it's equal to just f of x, that means it's even. If it's not equal to either, that means it is neither odd nor even. So just to summarize, so if we find f of minus x, if that's equal to f of x, that means we are looking at an even function. And if it's equal to f of minus x, minus f of x, this means we have an odd function. Okay? Alright? So, what we're going to do with each of these 3 parts is we're going to test, are they odd or even? Now, some of them you may just know that they are odd or even just by looking at them. Okay? Now, I'm not going to assume that. I'm going to test them all. but you might just be able to skip this step if you can remember that they're odd or even. Okay? So let's start with this one. So I'll call this one here f of x. Okay? So f of minus x is equal to minus x take 1 cubed. Okay? Now this is not equal to minus f of x or f of x. So this is neither odd nor even. Okay? So we just have to leave that one for now. Now if we take the next one, sine x, okay, I'll call this one g of x. Okay? Now g of minus x is equal to sine of minus x, which is equal to minus sine x. So this one is odd. Okay? Now then we take our last function, and let's call this h of x. So h of minus x is equal to minus 15 times minus x, which is equal to 15x. Now this one is equal to minus our original function. Okay? So this one is also odd. Now what this tells us is that if we break this integral up into 3 parts, okay, so if we've got the integral from minus 1 to 1 of x take 1 cubed, plus the integral from minus 1 to 1 of sine x, minus the integral from minus 1 to 1 of 15x, then we've just showed that this one is odd, this one is odd, and so therefore, because we're integrating from minus 1 to 1, this one will be 0, and this one will also be 0. So what we end up with is simply this last integral here, okay? And so we just need to do that one integral. So the integral that we need to do is just the integral from minus 1 to 1 of x take 1 cubed dx. Because the others are all equal to 0. Sorry, I'll just turn the lights off. Hopefully get rid of that glare. Okay, so this integral we just do now normally. So this will be 1/3 of x take 1 over 4 of x take 1 to the 4 from minus 1 to 1. So this will be 1 over 4. Substitute in our values. So put in 1, that gives us 0. Put in minus 1, okay, that gives us minus 1, which is minus 2 to the 4, which gives us 16. So 0 minus 16. So this would be minus 4. Okay? So our integral here is simply minus 4. Because we simplified it by checking that these two were odd. Alright, part B. So we've got the integral from minus 2 to 2 of x cosine x plus sine squared pi x on 4 minus 10x cosine x dx. Okay. Now, I'm not going to do this one in the same way, but you can test it yourself. So this one here is odd. Okay. So you can test exactly what we did before. Find f of minus x, put it in, and you'll find that it's an odd function. All right. Now, in the same way, this one here is also odd. All right, and again, you can test that by checking the values. Okay. So what that leaves us with is this integral is simply the integral from minus 2 to 2 of sine squared pi x on 4 dx. Because these two integrals are just 0. So now we just need to integrate this. Now to integrate this one, if you test this one, you actually find that this function is actually even. Okay? So, this one here is even. Alright? And again, you can check that. Now, because it's even, we can actually just rewrite this integral as the integral from 0 to 2 and multiply it by 2 because of our property of even functions. Okay. Now, to do this integral, I need to use some substitution for sine squared. So I'm going to substitute in 1/2 minus 1/2 cosine 2x. Now, because it's 2x, it's 2 lots of this, so this will end up being pi x on 2. Alright? So we've substituted in using one of our properties for the double angle. Okay. Now, if we multiply this 2, we've got the 2 with the half and the half, so this will just cancel out. This will just be 1 minus this, which we can now integrate. So this will be x minus 2 over pi sine pi x over 2 from 0 to 1. Now the reason it's 2 over pi is because we need to divide by the derivative of what's in here using the chain rule. So instead of multiplying by pi over 2, we divide by pi over 2, which is the same as multiplying by 2 over pi. So now we can substitute, oh sorry, that should be 2. So now we can substitute our values, so put 2 in, so we get 2 minus, now if we put 2 in here, we get sine pi, which is 0. Okay, and then subtract, if we put 0 in, we get 0 minus 0, so all up, we simply end up with 2. So we've simplified this again by using the odd and even function so that we don't need to do complex integrals. Alright? Okay, the last part, part C. Okay, so part C is the integral from -1 to 2 of x cubed plus 2 cosine pi x. Now, this time, because this question is about odd and even functions, you might be tempted to say, oh, this is odd, and this is even. However, you need to check your bounds here. So this is actually from -1 up to 2. So because the bounds are not equal on either side, you cannot use the even and odd properties. So we're just going to have to integrate this one normally. Okay? So this will become x to the 4 on 4, and this will be plus 2 on pi sine pi x from -1 up to 2. And then we can substitute values in. So put in 2, this will give us 4 plus 0 minus, put in -1, so that will give us 1 over 16 minus 0. So 4 minus 1/16, which will be, again, you can write it in different ways, but basically this will give us 15 over 4. Okay. Oh, sorry, this should be 1 over 4. Sorry, my bad. Okay. So we end up with 15 over 4. Alright guys, hopefully this has been useful. Make sure you check your answers. If you've got any questions or anything that you don't understand from the video, please let me know. Alright, other than that, have a good week and I'll see you next week.